This student book belongs to a set of student books which altogether provides the complete set of information to master SDMX. This student book helps you to understand the data structure definition and contains an exercise to build such a data structure definition. The video Introduction to SDMX is recommended to gain a global view of the basics of SDMX, including the data structures. This student book looks at the relation between statistical tables and data structure descriptor concepts, the design steps and the details of a data structure definition, the construction of a data structure definition with the Data Structure Wizard tool. Exchanging data requires a common standard. Only looking at a number won't say anything about its meaning. What is its subject? What units does it measure? What country does it apply to? At what frequency was it measured? When was the measurement taken? The table we just saw is a time series presentation showing data over several years. As it is illustrated in the following statistical data cube, data can be presented in a time series or cross-sectional. 3 dimensions, country, time, and tourism activity are shown in the cube. For the tourism activity B010, tourist campsites, the time series slice for Italy shows the annual numbers of Italian campsites. If we fix the time at 2006, a cross-sectional slice is shown. Its values at level B010 correspond to the number of tourist campsites for 2006 for the 4 countries. SDMX 2.1 supports and allow any representation creating the DSD. Let's imagine we have to describe our table for tourism statistics in a standard way. Take a simplified table, 3 tourism topics for the year 2007. What does SDMX need for describing a statistical table? First of all, we need to identify a set of statistical concepts. We can identify the following statistical concepts: frequency, in this case annual, country, tourism indicator, tourism activity, time period, the observation value, which is the actual single figure, the observation status, defined by footnotes such as estimated or provisional, and the unit, identical for all the figures. To summarize, frequency, time period, country, tourism indicator, and tourism activity are required to identify the statistics. They act as dimensions. The observation value, the actual figure, is what we call measure. The observation status and unit further explain the figures as an attribute. We can see that they are displayed at different levels of the table. This depends on whether the attribute explains only a single figure, a group of figures, or the entire table. In our example, the unit explains the entire table. It is attached at dataset level. The observation status explains only single figures. It is attached at observation level. In SDMX, it is also possible to attach attributes to a group of observations. This is not the case in our example. The result of our small exercise is a formal definition of the corresponding data structure. Of course, apart from the structure, we need to know how the concepts need to be coded in the data exchange. To finish the data structure definition, also called DSD, with all the structural metadata of the table, we need to look into code lists. From this table, we derive a more detailed table that includes all the information about the SDMX objects used in the DSD. From the final table, we can produce the data structure definition in XML format. Concepts act as identifiers and descriptors of the data. A concept consists of an identifier reference area, names, and descriptions. Names and descriptions can be stored in multiple languages. A code list is a set of values to be used in the representation of a concept, dimension or attribute, in data and metadata structure definitions. Examples are the code lists country and tourism activity. Each code is defined uniquely by a value and a description that can be provided in several languages. From SDMX 2.1, partial code lists can also be exchanged. The content of the partial code list is specified on a constraint. This enables using common and often quite large code lists in multiple DSDs and then constraining their content for use in a specific DSD. In our example, the list of countries is limited to 4 codes. To ensure the maximum interoperability in the exchanges of statistical data and metadata, the SDMX standard includes content-oriented guidelines and a standard XML format. For harmonization, the standard comprises a set of recommendations for the use of cross-domain concepts and code lists. The figure visualizes the relations between the elements of a data structure definition. It is formed by 4 sets of concepts. The dimensions, comprising the time dimension and the group dimension descriptor. Group dimension descriptor represents subsets of the entire dimension list to which attributes can be attached. The attributes are providing more information about some part of the data set. Each attribute must be assigned to a so-called grouping or attachment level. The primary measure, defining the observation value of the data set. The measure dimension, comprising 1 or more measures. The DSD links to other artifacts from the information model. Concepts are gathered in concept schemes. The values of a concept in a dataset are taken from code lists or have text or numeric formats. The steps to build a DSD consist in the identification of the descriptor concepts dependent on the type of data representation, the choice or definition of code lists for coded concepts, the definition of the text format for non-coded concepts, the definition of the role of the concepts, defining the dimensions, defining attributes with their attachment levels, defining the primary measure, defining the measure dimension, creating the defined components as SDMX artifacts in a data structure definition tool. Now we see how to proceed to these steps in practice. We built an SDMX 2.0 DSD using the Data Structure Wizard tool. With that tool, the following artifacts can be created: organization schemes, code lists as flat lists or hierarchical ones, concept schemes, data structure definitions, data flows, category schemes. In order to create any of the other artifact types, at least an organization scheme has to exist in the system. In order to be able to create a data structure definition artifact, at least a concept scheme and a code list must exist. Thus, the first 4 artifacts are essential to create a data structure definition. They are covered in the following example with the data structure wizard. The organization scheme is usually predefined and contains the relevant actors, so-called agencies, involved in the data exchange. These agencies are defined in the Organization Scheme Elements tab. To create a new code list in the application, click on the Code Lists node. A child node of Code Lists appears marked with ++. On the right pane, a new Code Lists page with the Code List Information tab is displayed. In order to create a code list, fill in the mandatory fields, highlighted in yellow and marked by an asterisk, from the Code List Attributes panel and Code List Properties panel sections. In the Code List Attributes panel, the user has to fill in the mandatory code list ID CL country and then select the agency ID ESTAT for the maintaining agency Eurostat. The version field may be provided by the user, but if it is omitted, the version is considered as 1.0 for a new code list or consecutively increased. Optionally, the other fields can be completed. If the Is Final checkbox is selected, the artifact is protected against modification and can be referenced by other artifacts, for example, by a DSD artifact. In the Code List Properties panel, the user has to fill in the mandatory Names field with at least one localized description of the code list. Country code list for tourism is entered. In the Code List Elements tab, the codes need to be defined. After pressing the New Code button, the code AT is entered in the Value field. The localized code description, Austria, is provided for the Descriptions field. The Save Code button adds the information in the upper main table section. The steps are repeated for each code to be entered. The Remove Code button would delete a code after its selection. To view the codes created as a code tree, the user must press the Tree View button. At the end of the definition, the new code list should be saved by pressing Save Code List. If the Is Final checkbox was selected in the Code List Information tab, the artifact is protected against modification and can be referenced by other artifacts, for example by a DSD artifact. As a result, the tree from the left pane of the screen is refreshed to display the newly created code list. The name of the new code list is a combination of the ID, agency ID, and version, which uniquely identifies it. To create a concept scheme, select the Concept Schemes artifact node from the left pane. A child node of concept schemes appears marked with ++, and a new concept scheme window is opened on the right side. In the Concept Scheme Attributes panel, the ID Tour Concepts is filled in and the Agency ID stat is selected. The version, if not provided manually, is considered at 1.0 for the first concept scheme. Optionally, the other fields can be entered. Selecting the Is Final checkbox before saving protects a saved artifact and allows referencing it. In the Concept Scheme Properties panel, in the Names field, Concepts for Tourism is entered, and the respective description field for each language may be completed. In the Concept Scheme Elements tab, the concepts belonging to the scheme are defined. In the Concept Properties section, the user presses the button New Concept. This adds a new grid line in the top table section. The ID field Unit and the Names field Unit of Measurement must be entered for the new concept Unit. Since the concept has coded values, the link to the code list CL Unit needs to be selected for the default representation field. Pressing the Save Concept button stores the definition and displays it in the table section. The steps are repeated for each concept. For the cross-sectional measure concepts AT, ES, FR, and IT, the parent concept Country has to be entered in addition. At the end of the definition, the concept scheme is saved with the button Save Concept Scheme. The new concept scheme is added to the concept scheme tree on the left pane. Now, the definition of the DSD can start with the created artifacts. After clicking on the DSD artifact, a new DSD window displays on the right side of the screen. In the DSD Information tab, the DSD's attributes and properties are defined. The ID DSD Tour CAP XS is entered and the agency ID SStat is selected. The version is kept as 1.0. The other fields, valid from, valid to, URI, URN, and is final, are optional. The URI field is pointing to the related SDMX structure message. The valid from and valid to may hold validity information of the current DSD. The Universal Resource Name, URN field, can hold a valid SDMX registry link. If the Is Final checkbox is selected, the artifact is protected against modification and can be referenced, for example, by a data flow based on this DSD. In the DSD Properties panel, the localized names Tourism Capacity Cross-Sectional is entered, and optionally the respective description field may be keyed. Within the tab DSD Elements Primary Measure, the related concept has to be specified. After pressing the button Choose of the Concept field, a pop-up window displays where the concept ops value is selected. In the DSD Elements Dimensions tab, the dimensions of the DSD are defined. To add one, the New Dimension button is pressed. The type of the dimension, frequency dimension, is selected from the Role drop-down list. Then the concept FREC and its code list is chosen. For a cross-sectional data organization, the attachment level section is selected and the frequency dimension is saved. Again, we press New Dimension to define the country measure dimension following the same steps. Here, for cross-sectional data organization, the attachment level is observational. After clicking Save Dimension, the updated dimensions are displayed in the top table section. Once the time dimension, time period, and the tourism-specific dimensions, tourism indicator, and tourism activity are defined, we switch to the group keys. Within DSD Elements group keys, the user may declare any useful groupings of the declared dimensions. Such declarations form partial keys to which attributes may be attached. One possible grouping is the so-called sibling group. Add a new group by pressing the New Group field and fill in the name of the group key, sibling, in the Group Key ID box. Then, the dimensions which form the group key are selected from the Available box and transferred in the Selected one. Save the group by pressing the Save Group button. In the DSD Elements XS Measures tab, the definitions for the cross-sectional measures, XS measures, are enabled since a measure dimension was defined. Here we link the 4 cross-sectional measure concepts to the country measure dimension. In the Concept field, choose the concept, AT, for the first cross-sectional measure and select the country code list. In order to save the cross-sectional measure, press the Save XS Measure button. These steps are repeated for the other cross-sectional measures, France, Italy, and Spain, before moving to the Attributes. DSD Elements Attributes tab, a new attribute is created by pressing the New Attribute button. Choose the Ops Status concept and the related code list CL Ops Status. Then select an Assignment Status, Conditional, and the Attachment Level, Observation. This Assignment Status Conditional indicates that no value has to be provided for this attribute in the data file. Mandatory would mean that the value must be present. Attachment level options are Dataset, Group, Series, and Observation. The attribute type should be defined for special attributes. For the example, the time format attribute will be marked as time format. In the cross-sectional attachment level section, the attachment level for the cross-sectional data organization needs to be defined. Optionally, the text format section can be filled to specify the accepted format for the attribute's values. Since observation is selected as cross-sectional attachment level, the attachment measure section becomes enabled. The measures to be used for attachment of this attribute have to be moved from the Available list box to the Selected one. If Group was selected for another attribute as attachment level, the Attached Group ID section would be enabled to choose the group for this attribute's attachment. To save the attribute currently edited, press the Save Attribute button. To save the entire data structure, press the Save DSD button. The name of the saved data structure definition is shown in the left pane in the DSD's tree. To save again, after selection of the Is Final box, protects the defined DSD against modifications and allows referencing of the DSD by other artifacts, such as a related data flow. To save further modifications of a DSD marked as final, the version needs to be increased to create a new instance of the DSD. As a result of the DSD definition, the SDMX ML structure files are created in the XML subdirectory of the data structure wizard root directory. The folder key family contains the new DSD structure DSD tour cap xs plus stat plus 1.0.xml. SDMX is sponsored by 7 international organizations since 2001. If you want to know more about it, look at sdmx.org, which provides the technical standard and guidelines and also links to other resources, such as the Eurostat SDMX InfoSpace, including other self-learning tutorials on SDMX.